Let's look at this example. We have a truss structure supported by two pin supports at point A and point B. And we also have some applied forces. We need to, again, determine the force in each of the truss members. For this problem, again, we will try to find any zero force member, but we actually can't find any. Member CE is the one that looks most likely that it's a zero force member because it is at an angle with two collinear members. However, it is not a zero force member because of this force right here. So we have an additional force acting at point C. For that reason, you cannot say that member CE is a zero force member. We also try to determine if we need to solve for any support reactions first by treating the entire structure as one system and apply rigid body equilibrium analysis. But in this case, we actually can't because we have two pin supports. So at each pin support, we will have two support reactions. So that will be overall 4 support reactions. And if we treat the entire structure as one system and try to apply the rigid body equilibrium analysis for a 2D rigid body free body diagram, we can write a maximum of 3 equations, enabling us to solve for 3 unknowns. So we don't have enough equations. So at this point, we are going to start with solving for one of the joints, and we're going to look for the easiest one, which is going to be the one that has only 2 or less unknowns. In this case, point D is the one that satisfies that requirement. So at point D, we have a known 600 Newton force, but also we have 2 unknown forces from member DE and CD. So we're going to start our method of joints with joint D. So at joint D, we have the known 600 Newton force, and we draw the unknown forces again in tension, FCD and FDE. So notice again, we have a 3, 4, 5 triangle. This is a 6 meter. Together, that's 8 meter. Therefore, along the AD, that's a 10 meter. So recognizing that, it will make the resolving the force a lot easier. Again, we're using the conventional X and Y coordinate system. Therefore, along the X direction, we have the X component of FDE, that is a negative FDE times 3/5. And then we have another 600 Newton force also pointing to the left, negative X direction, and that equals to 0. And then resultant force along the Y direction, we have negative FDE, its vertical component, that's a 4/5, and then minus FCD, because it's also vertical down, and that's also 0. So based on these 2 equations, we can solve for our 2 unknowns. So from the first equation, we can solve for FDE to be negative 1,000 Newton. Negative sign indicates that it's actually in compression, and we substitute that into the second equation, and we can solve for FCD, and that's going to be 800 Newton in tension. So we have solved for FDE and FCD. I like to mark them on the structure so that we know that, oh, okay, these 2 have already been solved. Moving on, the easiest one next is probably joint C, because now joint C has only 2 unknowns, CE and CB. Therefore, we're going to, again, draw a free body diagram of joint C. Applied 900 Newton force. Now, CD has already been solved for, that is 800 tension. So in that direction, we always draw the correct direction for the known forces. 2 unknown forces, we assume they are in tension as well. So this is relatively easy to solve for because we only have force components along the X and Y direction. Therefore, from here, we can solve for FCE, that is negative 900 Newton, which is a compressive force, and then FBC is going to be positive 800 Newton. That's a tensile force. So again, we have solved for these two. I'm going to mark them on my drawing as well, here and here. Moving on, we can solve for joint E. At this point, we do not want to pick A or B because for joint A, we will have three unknowns, AX, AY, and FAE. For joint B, we will also have three unknowns, BX, BY, and FBE. So the only option at this point is joint E. Because joint E only has two unknowns, BE and AE. So we have known force FDE, that is negative 1,000, so compressive 1,000 Newton pointing towards the joint at point E, and this is the compressive 900 Newton from FCE, and then our two unknowns. Here we have FAE, and then we have FBE. So it's really up to you at this point if you want to realign your XY coordinate system. If you say I'm going to pick my X direction to be here, Y direction to be here, that's fine. But for me, because of this nice 3, 4, 5 triangle, I don't think it's so much inconvenient to stick with the conventional X and Y coordinate system. So that's still what I'm going to do. So along the X direction, we have FAE pointing towards negative X direction with a component of 3/5. The same thing with the 1,000 Newton force. And then along the negative direction, we have 900, negative X direction, the 900 force. And then we have FBE's component that is along the positive X direction, that is 3/5 along the X direction, and that equals to 0. All right, resultant force along the Y direction. So both FAE and the 1,000 Newton force have negative components along the Y direction, 4/5, and then FBE also has negative components along the Y direction. All right, so again, two equations, two unknowns, FAE and FBE. So from here we can solve for both of them. So FAE equals to negative 1,050 Newton, negative sign, that is compressive force, and then FBE equals to 750 Newton, tensile force. So in order to solve for these two, you have to solve two equations simultaneously. If you realign your X and Y direction, so if you have X and Y in this direction, then along the along the Y direction, FBE is the only one that has component along the Y direction. So you can write an equation along the Y direction with only one unknown. That helps simplify the calculation. Or like in this case, I don't mind solving two equations simultaneously, so I was sticking to the conventional coordinate system. It's really your preference.